here is another integration by parts, couple of examples. So integrating x times cosine x, again I'm using late as the acronym for what I want to pick for u. I don't see any logs, but I do see what I call an algebraic term, or algebra term, which is just the power of x. I have x to the first. So I'm going to pick u equal to x. And the other way to remember how to pick u and dv is that dv should be the most complicated thing that's still relatively straightforward to anti-differentiate. Cosine is definitely more complicated than just x, and we know how to anti-differentiate cosine. So I'm going to pick u equal to x. dv has to be everything else. The du, well, the derivative of x is just 1, so du is 1 times dx. V, the antiderivative of cosine of x, is positive sine of x. Just like the derivative of cosine of x is negative sine of x. Alright, so rewriting my integral, and I often like to actually write the integral again. So the integral of x times cosine of x dx is u, which is x, times v, which is sine of x, minus the integral of v, sine of x, du, which is just dx. So you're never actually writing the u's and v's, you're just replacing what u and v are equal to, right? So just as a reminder, right? This is u, this is v, this is minus the integral of v du. And the whole point is that now this thing is easier to integrate. And we can say that this is equal to x sine of x minus the integral of sine. The integral of sine is negative cosine. Because the derivative, so for sine and cosine, it's always the opposite. So the integral of sine is negative cosine because the derivative of sine is positive cosine. Or because the derivative of negative cosine is sine. So you get minus and minus cosine of x. And we should definitely rewrite this as x sine of x plus cosine of x plus c. If you really wanted to, you could check that this is right by taking the derivative. The derivative of x sine of x plus cosine of x. I'm not going to write the plus c because we know the plus c, the derivative is 0. Here I'm using the product rule. I'm getting 1 times sine of x plus x times the derivative of sine is cosine of x. And then plus the derivative of cosine is negative sine. And look, the sine here and the negative sine are cancel out and you get x cosine x, which is exactly what we were anti-differentiating. Alright, similar but slightly different example over here. X times cosine of 4x. So when I do this, I'm still going to pick u equal to x, and dv now has to be everything else, which is cosine of 4x. du is still 1 times dx, or just dx, and v, so this is where you would maybe have to use a u sub, but I don't want you to have to use sub. So the whole thing here is that, right, since the derivative of cosine of 4x, the chain will make you multiply by 4, the antiderivative has to make you divide by 4. And my antiderivative here is either, you can say it's sine of 4x all over 4, or you might prefer to say it's 1/4 times sine of 4x. I kind of like writing it the first way. But the whole reason here is because if you take the derivative of this, the derivative of 1/4 times sine of 4x, right? If you take the dv dx, oh, I forgot my dx here, sorry. It's equal to 1/4 times the derivative of sine of some stuff is cosine of the stuff times the derivative of 4x, which is 4. And that 4 cancels with that 4. And so your dv dx is exactly cosine of 4x. I want you to be able to anti-differentiate cosine of 4x without having to write out the whole u substitution. You could write the u sub, it's a pain in the butt. Right? If I did that, you could say, oh, so to find v, I'm going to integrate dv, which means I'm going to integrate cosine of 4x. I would do a u sub at u equal 4x. du would be 4 dx, 1/4 d, right? This is so much work. And then I would write this as the integral of cosine of u times 1/4 du, putting the 1/4 out in front, and then I integrate that and I get 1/4 sine of u plus c, which would be 1/4 sine. Wow, that's a lot of work. But you do see that we get the same result, right? The integral of cosine of 4x is sine of 4x divided by 4. So if you're ever integrating something where you have a multiple of x, you're going to be dividing by that multiple. So, long story short, u is x, dv is cosine of 4x, du is dx. And the antiderivative cosine of something times x is sine of that same something times x divided by the multiple of x, which is 4. This ends up equaling uv minus the integral of v du, which is 1/4 sine 4x dx. So then integrating this, I'm going to get, I'm going to write this as x times sine of 4x all over 4 minus the integral of sine of 4x is going to be negative cosine of 4x divided by another 4. So I have minus 1/4, and the integral of this is negative cosine of 4x all over 4. Again, the derivative of negative cosine of 4x all over 4 is positive sine of 4x times 4, and the times 4 divides the 4 there. So we're just kind of undoing the chain rule in a very small way. And then finally I would simplify and get x sine of 4x all over 4 plus cosine of 4x all over 16 plus c. I don't think it's necessary to get the common denominator here and write it as like 4x sine of 4x plus cosine of 4x all over 16, but you could if you want.